One sign that a chemical reaction has taken place is a change in temperature. Some reactions are exothermic, which means that thermal energy has been transferred from the reactants to the environment, causing an increase in temperature. An example of an exothermic reaction is the combustion of fuels. In endothermic reactions, thermal energy is transferred from the surroundings to the reactants, and the temperature of the reacting mixture decreases. Endothermic reactions are used to make cooling packs to treat injuries.
You can investigate energy changes in reactions in the classroom. There are different things you can investigate, but some important points apply to all the investigations.
Firstly, you need to use an insulated container to carry out the reactions. This will ensure that energy transfer with the environment is kept minimal, making your results more accurate. You can use a polystyrene cup with a lid, or place a glass vial in a beaker and surround it with an insulating material like cotton wool. If you decide to use a cup, it's a good idea to place it inside a beaker so it does not fall over.
You will also need to measure temperature changes using a thermometer. The thermometer will need to be placed in the container with the bulb placed inside the reacting liquid, but not touching the bottom of the container. A long 30 cm thermometer is preferable as it is easier to read accurately.
Make sure that the thermometer takes measurements to the nearest 0.1 degrees Celsius rather than to the nearest degree Celsius. This means a high resolution. If there is a problem with your thermometer, it may result in systematic errors. These cause readings to differ from the true value by a consistent amount each time a measurement is made. Their effects cannot be reduced by carrying out repeats, so if you suspect your thermometer is not measuring temperature accurately, you should swap it for another one and repeat the measurements.
For all of these investigations, you will be measuring the temperature of one reactant at the start, the initial temperature. You will then add the other reactant and record the most extreme temperature reached. This is the final temperature. You will need to calculate the temperature change. If the reaction is exothermic, then the temperature change will be a positive number. If it is endothermic, it will be a negative number.
In order to reduce the effects of random errors, it is good practice to repeat your measurements. You will need to calculate a mean. This is done by adding up the temperature changes for the repeats and then dividing this number by the number of repeats.
For example, a student carried out a neutralization reaction. She measured temperature changes of 3.4 degrees, 3.6 degrees, and 3.5 degrees Celsius. The mean is 3.4 plus 3.6 plus 3.5, which is 10.5, divided by 3. The answer is 3.5 degrees. A simple investigation would be to work out the energy change during some different reactions. You could try neutralization, metal displacement, metal plus acid and acid plus carbonate.
You could also choose one reaction and investigate how a variable affects the temperature change. For example, the neutralization reaction between hydrochloric acid and sodium hydroxide is exothermic. You could change the volume of sodium hydroxide to see if there is an effect on temperature change.
These results can be plotted as a line graph, with the independent variable, volume of sodium hydroxide, on the x-axis, and the dependent variable, which is the temperature change, on the y-axis. This will allow you to see any patterns in the data more clearly.